Hello participants, once again welcome to this e-learning course on chromatography. As you all know, you have the schedule. We are going to start today with high performance thin layer chromatography. Before we go on with this titled talk, please look into the brochure or the flyer or the advertisement you had. There is a printing mistake over there. It is by mistake written high pressure thin layer chromatography. I will justify it in our talk itself that Hptlc can always be referred as high performance thin layer chromatography only. You cannot refer it as high pressure thin layer chromatography. So mind this point very well, that it is more attributed as high performance thin layer chromatography. Over here I have mentioned a tagline, an ultimate advanced modification of TLC. And as and when we will surpass through this talk, we will justify this statement that it is one of the most advanced modification ever been happened in thin layer chromatography. So how did this Hptlc came into emergence? How did it came into existence? Friends, after the mobilization of TLC technique and its practice among the researchers and the industrialists, TLC plates became commercialized. How? The glass which was used as a support on which silica was stuck got replaced by aluminum plates. And these aluminum plates then were started marketing and were reached to the industries as well as to the researchers. So these plates were now commercialized and it was pre-coated with silica. And even it was seen that as they were pre-coated, the particles that were coated on it were of small size and its effect was observed on separation and resolution. Separation and resolution in the form of RF values and the plate heights, which to an extent I have explained you in the last talk. So it was observed that when the plates were prepared using the traditional method of pouring it on the glass and drying it, the particle size and the layer were a bit thick because it was more of a human intervention. But when that was replaced on an aluminum sheet, it was a type of a machine work that was done, and hence the particle size could reduce. Uniformity could obtain. So this was how an idea came in the mind of the researchers that if a small particle, tiny particle, uniform layer could apply, it could result in to good resolutions. Therefore, plates were upgraded with small size silica. And these plates are today called nanoplates. And this was the point from where introduction of Hptlc in research and industry began. Today, we are going to discuss more about Hptlc. But we also want to prove that the statement an ultimate advanced modification of TLC. And when you are modifying something, there should be some good thing that helped us to modify or to overcome the old. So before going into that, I'll just make you recall the whole procedure of TLC because it is very much needed and required over here. So we will just play this video and go through it. The video actions are important for this particular video and not the audio.
To use some silica which has been sprayed onto an aluminium sheet. This is called a TLC.
See, this is that aluminium sheet on which silica is being coated, and these types of plates are today sold commercially where the TLC experiments are conducted.
plate. We use the properties of the silica and the properties of a solvent to draw the compounds up the plate at differing rates depending on the characteristics of the compound. First of all, we need to make a TLC spotter. Heat the centre of a capillary tube in the blue cone of a micro Bunsen burner.
The capillary, which we generally use for melting point and boiling point, is being broken into two by stretching it in the flame, so it will give a nice point which can be used to make the drop of analyte on our TLC plate.
Flame. Rotate the tube gently to ensure it's heated evenly. and when it starts to give, take the tube out of the flame, leave it for a split second, and then sharply pull out both ends of the capillary to form a very fine tube. Allow this to cool, and then snap the tube to produce 2 spotters. We've drawn a pencil line at the bottom of the plate with 3 marks on. We're going to spot one of the samples on the left-hand spot and the other on the right-hand spot. We've put a spot of each compound on the middle co-spot so we can...
Remember over here, I am speaking a line that in this experiment of TLC, human intervention is there. The spots that are being marked and the analyte sample that is being placed is by a human activity or a human hand.
compare their RFs. We need to put the solvent into the chromatography tank to a depth of 3 to 4 millimeters. Usually you'll be told what solvent to use. Put the plate into the tank and put the lid on. You'll see there's a piece of filter paper in the chromatography tank, which is a beaker. This helps to saturate the atmosphere with solvent vapours. Once the solvent front has got to the top of the plate, remove the lid, take the plate out and draw a line where the solvent front is so you can work out your RF values.
See, first of all, they are marking the level up to what the mobile phase has ran.
There are a few ways to visualise TLC.
This method, where a UV light is being applied over it, it is, if you remember, the non-destructive method of visualization. So this is the non-destructive method of visualization by which you are trying to visualize the spots that have been obtained.
Plates. If the compounds are UV active, you can see spots of the compound under a UV lamp. Use a pencil to circle the spots. A range of chemical dips can be used which react with certain functional groups producing a colour change, for example potassium permanganate.
Why is this chemical dip done? Sometimes if you don't get the spot clear, you go for a non-destructive method replaced by this destructive method of visualization. If it is dipped in iodine solution or potassium permanganate solution, it will undergo redox reaction and the spots will appear. So friends, this was that basic experiment of TLC that we have already known in our previous talks, and today we have recalled it. Now, what are the qualities of Hptlc? It is a type of planar chromatography and a sophisticated version of TLC with several scientific enhancements. Compared to TLC, over here, as the sheet is always alumina and never glass, the powder in the form of stationary phase stuck to it in the form of a coating is always small sized and high quality. So the stationary phase is upgraded. Over here, automated sample application will come into practice. In the previous video, the reason for keeping it over here for such a long duration was you could see over there that a person was keeping the spots on the plate. Over here in Hptlc, the first human intervention will be replaced by a machine. Minimum sample preparation, full optimization and increased resolution of components, and densitometric scanning. Friends, apart from point 1 and 2, I have not gone in details of 3, 4 and 5 because they are going to come at the later stage. But these were the qualities of Hptlc that has made it that much popular that in few of the natural product chemistry today people are choosing Hptlc rather than going up with TLC, proving Hptlc to be an advancement in TLC. What are the points that can prove that Hptlc really is an advance in TLC? Number one, Hptlc is a total automated technique, whereas TLC is a total manual technique. Number two, Hptlc always has a pre-coated stationary phase, that is a sheet of alumina on which a silica gel very fine layer is coated. But the traditional TLC, we can even have a handmade coating using glass as a support. The spot in HPTLC is circular, whereas the spot in TLC is rectangular. Friend, pardon me, here there is a simple mistake that I have committed, and that will be overcome in the upcoming ePDF that is provided to you. There is a simple mistake that has been done over here and which I could realize during this recording. And as 8 to 9 minutes of recording is done, pardon me, I won't re-record, but the spot is circular, is in TLC. Size of the sample is uncontrolled, it is TLC. Not compatible with PC, it is TLC. And manual calculation, it is TLC. So point number 3, 4, 5 and 6 are in TLC. Very sorry for that. And spot is rectangular. Size of the sample is controlled, compatible with PC and software operated. These last 4 points will come in HPTLC. So simple error in documenting the thing on the presentation. The last 4 points in both the sections have to be swiped. I am really pardoned for that. On basis of these properties of being automated, only pre-coated plates, a rectangular or a fixed spot size, length and breadth, size of the sample to be controlled, compatible with PC and software operated, HPTLC becomes a more robust, simple, rapid, efficient, and a better resolution technique compared to TLC, and this brings HPTLC to be to a more advanced level than TLC. So these are the points which makes HPTLC more advanced and more to be chosen in place of TLC, especially in natural product chemistry and drug chemistry. Principle is exactly similar to TLC, that in this technique, mobile phase is driven by capillary action and carries various components. Depending upon their affinity towards adsorbent, the components exhibit adsorption on the stationary phase. The component with larger efficiency for stationary phase interact with the surface and move slowly in the mobile phase, whereas the component with lesser affinity for the stationary phase moves fast. So friends, this is a principle, so I have to write it as such. It is given in few references. So there is no more explanation now needed to the principle on what separation occurs. We are very much versed with the absorption as well as the partition phenomena as a principle in various chromatography techniques. What are the key features of HPTLC? A complex information about a sample can be obtained in the form of a very good visible chromatogram. Sometimes in TLC, the spots are not visualized very well, even after destructive or non-destructive visualization practice. But in HPTLC, there will be a separate visualization machine connected to a PC that will visualize sample. It's RF for us. We do not have to take a pencil and calculate the RF in HPTLC. So this is how the word performance is justified. The performance compared to TLC is much better. Simultaneously, both samples and standards analyzed. This point seems to be a little confusion, that even in a broader TLC we can analyze simultaneously, but the number of spots that can be simultaneously analyzed in HPTLC can be much more than in TLC, which you will see when you are going through the experimental part of HPTLC today in this talk. Automatically converts visible chromatograph into peak data. This is one of the most important point of HPTLC, that when the visualizer will see the spot, it will calculate its area, its intensity, and depending upon that, it will create a graph which is called chromatogram. And using a TLC, just visualizing it with our naked eyes, we do not have any potential to convert it into any graphs. So this is the second important point which helps us to justify the word performance. It is cost effective, low cost of maintenance, and no filtration and no degassing is needed of the mobile phase. So these are some of the key features which really makes HPTLC high performance thin layer chromatography. HPTLC instrumentation is a system of several different instruments. There can be 7, 8, 9 components, but I am going to focus on 4 important components of Hptlc instrumentation. First is the sample applicator. Instead of using a human hand to put the sample on the plate with the fine capillary, there will be a machine used which is called sample applicator. Then there will be a chromatogram development, that is the interaction of mobile phase and stationary phase with the sample. Number 3 will be the TLC visualizer, and number 4 will be the detection via data system, that is our computer. So these are the 4 which will together form Hptlc system. Remember once again, these are the minimum 4. There can be add-on instruments which we will see during our instrumentation preceding from this slide. The simple Hptlc flowchart, that is experimental. First of all, you need to select a layer, that is your adsorbent stationary phase. You want to now prepare the sample. You have a sample, you dissolve it properly in your mobile phase and move on. Application of the sample using the applicator instrument. Chromatograph development using the development chamber. Scanning using the scanner, and quantitative evaluation using densitometer measurements. And now we are going to go in possible basic details of each component or each system instrument that together forms Hptlc system, and we are going to focus on that points which really coins for it to justify the word performance. Number 1. Selection of the layer, stationary phase. In Hptlc, plates coated with small sized particles and narrow distribution is used. Thus, surface area of the plate is smooth. As the surface area is smooth, there will be no friction. Number 2, particles will be small in size. So, number of theoretical plates will be more and the separation will be better. So, high resolution, and it is a machine, so high accuracy and high precision. So, precision, accuracy, and resolution, you can call it performance, what you have learnt with me in Hptlc. The size of the plate that is used is comparatively small as compared to TLC. Over here, I want to make a correction. The size of the plate is comparatively big as compared to TLC. That is 10 into 10, 20 centimeter. So it will be a large TLC plate. We will see it in the coming up videos. The selection of Hptlc stationary phase is based upon the type of analyte. So what type of analyte is there? A similar type of plate stationary phase you will select. Friends, you have to remember very well, when I'll give you the ePDF copy, I'll correct it, but over here it is big, large, not small. Step 1. What are the different stationary phase that you will use? If you are interested for a normal phase, you will use silica gel. If you are interested for a reverse phase, you can use C18, C8, C4, C2 and phenyl. You know what these things are? These are carbon chains, non-polar stationary phase and henceforth reverse. You can use chemically modified silica gel, hydrocarbon impregnated silica gel. And when you say hydrocarbon impregnated silica gel, it means you are adding some hydrocarbon on silica gel and using it as a stationary phase. Chiral stationary phase, 18 column plus modified silica gel. Sometimes you even use optically active stationary phase to separate the optical active isomers, and others that include aluminum oxide, magnesium oxide, silicate, polyamide, cellulose, polar modified silica gel layers, etc. So just see, you have a huge number of choice of stationary phase that you can use in as an adsorbent or as an stationary phase in the Hptlc. So these are the different stationary phase from which you can select a stationary phase as that fine layer on the plate. Moving further, step 2, sample preparation. The sample may be prepared using either methanol, chloroform methanol, ethyl acetate methanol, chloroform methanol and ammonia, methylene chloride and methanol. Over here, I am not forcing you to remember, or I am not telling that these are the only possible solvents in which your sample can be prepared, but I am here denoting you to learn that this is an isocratic system, single solvent system. This two and the last one are the binary gradient system, and the one in the middle is a ternary gradient system. So I am just here showing you, focusing you that you can use one solvent as a solution or as a material in which you can dissolve your sample, or even you can use a mixture of two solvent or three solvent to prepare a solution. Now, as we are preparing a solution, we should closely look at what are the precautions we should take while preparing a solution. And for that, I have a very small video for you. You just look into it carefully and see how we are preparing a sample. If you look very carefully at this bottom of this small vial, there is a solid powder sample, and now they are adding a solvent or a solution depending upon the requirement to it, and they will prepare a sample solution. So friends, this was how you prepare a sample solution. At last, that black part which was used, it's a gun to close the cap very tightly because it is going to be used by a machine. Moving further, there are a few precautionary measures that are to be taken before the sample application. Where is the sample application to be conducted? It has to be conducted on a TLC plate. So what are those precautions? You have now your sample ready. It has been prepared in a solvent. Remember over here that solvent can be a mobile phase. Care must be taken while handling the plates to avoid contamination. You should always wear gloves, and you should catch the plate in such a way that your hands do not touch in any case on the upper part where the stationary phase is stuck. The plates should be covered under UV light to know any damage or presence of impurities. When you take a fresh plate, first of all put it under the light to see whether any pre-spots are there or not, manufacturing defects. The Hptlc plate should be pre-washed to remove the impurities. If at all sometimes you find such impurities on it, what you do, you just pass methanol through it. So methanol will run according to the capillary action, and all the spots will run and reach to the top of the plate, and your plate will be clean. The Hptlc plate should be pre-washed. The most common solvent used for pre-washing is methanol, chloroform, or the mixture. Why? Because they are low boiling, you can easily remove by just keeping those plates in oven. The plate kept in the open must be activated by placing in oven at 110 to 130 degrees centigrade for 30 minutes. You need to activate that small pores of adsorbent so that adsorption phenomena occurs. So let us first check that how this precautionary measure can be taken when we really have that large plate compared to TLC on which this HPTLC experiment will be conducted. Documentation of a clean plate. It's a precautionary step before applying the sample on the plate. You see, they are just keeping the plate inside the chamber, and they will see from outside whether any spots are observed or not. If spots are observed, then it has to be cleaned using methanol or chloroform by a simple capillary action run. So here you can see this is the image of the plate, and as it is under a UV chamber measured at 254 nanometer, it looks green, but you cannot find even a single spot on it. So it is very clean. So your precautionary step is now sample application is permitted. So let us check for sample application. Step 3, that is application of sample. The sample is applied with the help of some applicators. If you remember the TLC experiment, the capillary, fine capillary was the applicator with the human intervention. You can use these capillary tubes, you can use microbal pipettes, you can use micro syringe, and you can use automated sample applicators. Now these automated sample applicators are the best because in those the human interference will be the minimum, and we know, we have to believe, and we have to accept that compared to a machine, if a human is working on a machine or as a part of a machine, in few of the steps, when he is interventing, he will create some errors. And to minimize those errors, machine work with the same frequency, same speed, and same momentum, and so the errors are minimized. Using these applicators, sample can be applied in the form of spot or band. The concentration range is zero point 0.1 to 1 microgram per micro ml, because above this range, separation becomes poor. Friends, this is important. The concentration has to be between zero point 0.1 to 1 microgram per micro ml. When we apply, we might add a little bit larger amount of quantity. But we need to add highly carefully a very small amount of quantity with a very less concentration. Otherwise, adding a highly concentrated spot will make the separation very poor. And we can say with a surety that a machine can do this more better than what we can do. And as I have told you, and as I have received feedbacks from you, I have tried to add maximum video in this particular talk to make this machine much clearer to you. In this particular lecture, I am not focusing on chemistry much, because the chemistry of adsorption remains the same. The chemistry of attraction with the stationary phase remains the same. The one that is attracted more will remain in, the one which is attracted less will go out. But I am here focusing today on the instrumentation, which is highly important. So let us see that how this application of sample is made possible using an automated sample applicator. This is the instrument on which this application will be done. You can see over here there are few solvent reservoir tanks. This is an applicator. Over here there will be a needle. These are the samples filled, and over here we will put our TLC plate on which application will be done. So this is an application chamber where sample will be applied. Instead of using a human hand, you have a robotic hand moving with the same momentum, same speed, and no vibration. Just do one thing. I have an experience, henceforth I am telling. If you get a chance to apply a spot on a TLC plate someday using a capillary, when you will be applying it, your hand will be shaking a little, and that will broaden the spot. But if you use the machine, no chance of improper application of or improper placement of the spot. I can guarantee that. This is why using of instrumentation is leading it to a new name, that is high performance. So now let us go through this application of sample using this application chamber.
Hptlc software effectively leads you through the entire chromatographic process, step by step. Position the TLC.
So first of all, you can see the TLC plate has been positioned. And if you have observed, gloves are there, and the way he or she, we don't know, was catching the plate is very important. It was the minimum that the hand was touching on the white surface. Keep these things in mind.
Hptlc plate on the self-adjusting object support. After
See, these are the sample vials. If you remember, while preparation of the sample, we have used such brown colored glass vial. These are different vials that are filled with different samples and placed over here.
having loaded the ATS4, you can start the fully automatic sample application. Vision CATS displays the current status of the sample.
If you remember the comparison between Hptlc and TLC, where I have just committed a writing mistake and I told you to swap the points, it was written over there. One is a fully automated method where it is compatible with PC. So see this, it is compatible with PC. Your applicator is directly connected to a computer. You need to just give the commands to the computer, and computer will send the commands to the applicator, and applicator will perform the work that a human hand used to do.
Sample application and the expected end time. An application sequence starts by rinsing the syringe. Next, the septum is punched and the needle lowered into the sample vial, thus allowing the syringe to be filled with the sample solution. The septum punch is retracted.
You can see that this needle is just being pierced inside this bottle, and the sample is now loaded. The sample is now loaded into the syringe. and once loaded it will go onto the plate and get injected. The phenomena remains the same. What I told you just now, I'm not going to today focus on the phenomena much. I'm going to focus on the instrumentation and working much. You see, when you are collecting the sample, it is loading, and when you will apply it on the stationary phase, it will be injecting. Why I did like this? This is the surface and you are going to apply it like this. You will see just now. And one more thing, why I have paused the video, I'll tell you. If you go back to that comparison slide, I have asked you to swap those points. And after swapping, on TLC you have a round spot. Over here you will have to see a rectangular spot of your sample. Keep your eyes concentrated on the plate.
Extracted prior to the needle being removed to ensure the outside of the needle is wiped off by the tightly closing septum. The syringe moves to the programmed position of the plate and starts applying the desired sample volume. Several applications
See the perfection. See the rectangular shape of the analyte. I guarantee every time a human hand is not capable of doing it. But see, and now you will just see that this machine will do in this one single line 7 to 8 such spots, and see the perfection of this machine.
of the same sample are applied in sequence. Samples are applied as bands by default. Spots and rectangles can be applied as well. After the final application of the sample, the syringe is emptied into the waste and rinsed.
It is very lighter in color, but as I'm moving the cursor, you might get an idea. This whole line, dear participants, have at least 8 to 9 samples that have been applied by this syringe. So this is an automated application of sample on the TLC plate through this applicator.
Again, ready for the next application sequence. Once all samples are applied successfully, just open the cover and remove the applied Hptlc plate for chromatogram development, the next step of the Hptlc process.
So over here, there is an observation of these color spots, all at an equal distance and all at an equal quantity and concentration. So this is the importance of an automated applicator. Now it will be taken to the development chamber. Development chamber is nothing, but in the development chamber, there will be a chamber instead of a beaker. This big plate will be placed inside and it will be allowed to run for the basic fundamental of the chemistry between the sample, mobile phase as a carrier, and stationary phase as an retarding factor. So let us go and see the theme behind chromatography techniques and the one that is used in Hptlc. Development of chromatogram. The chromatogram development is the most important step in the Hptlc procedures. The Hptlc chamber is preconditioned with solvent to get uniform vapors of the solvent in the chamber. The chromatogram can be developed in 4 ways. There are n number of methods for the development, which include automatic multiple development, vertical method, horizontal method, and vario methods. Friends, as I have told you earlier, today we are focusing on the engineering or the mechanical part of the instrument, because this instrument is more to be learned mechanically rather than learning its chemistry. So we'll not go into detail as of now into all these 4 parts. They are going to be connected in the coming phases later on after 1 or 2 months, but we are directly focusing now on the mechanism of the instrumentation, how it's developed the chromatograph. The upcoming video has a little low voice, but over there also the voice is not important. Important is the mechanism, the mechanical work that is being done, and where needed I am pausing the video and going to explain. So do not worry, enjoy the development of chromatograph. See, this is a chamber made up of glass. At the bottom there is a mobile phase, and in this we are going to place our TLC plate. So see what happens.
Remove chromatography plate without touching
So
the
you are
sample.
removing the chromatographic plate from the applicator.
It is the twin trough chamber. It is left for chamber saturation up to 30 minutes.
You have to fill the mobile phase into this chamber and leave it for 30 minutes. And
It
after
is
that you
filled
will
with
be
10
placing
to
the
15
TLC
ml
plate.
of solvent, that is stationary phase, in the ratio of 5:5:1 of toluene.
Over here, the speaker even has made a mistake. She just now spoke that 5 is to 5 is to 1 ratio of stationary phase. It is not stationary phase, it is mobile phase. But do not worry, we are today focusing more on the instrumentation.
Ethyl acetate and formic acid.
See now the plate has been placed and it has been covered. And the mobile
Mark
phase
8
is allowed
cm
to
from the
run.
bottom on the chromatographic plate. Then immerse that chromatographic plate inside the twin trough chamber and allow the mobile phase to move over the plate.
See mobile
We
phase
will
line
never
can be
allow
seen over
that
here.
mobile phase not to move over the marked position.
Mobile phase has moved up to a level and now you are taking that plate out of the mobile phase and you are taking it towards the visualizer. What will this visualizer do? It will help you visualize the spots. If you go back to the first slide of TLC video, you are visualizing it using a chamber. Here also you will be visualizing it, but see what is the difference when we are talking of performance. So hope you have got the point. Development of chromatogram. Step 5 is the scanning or the visualization. The developed plate can be detected by using UV cabinet or UV chamber, which provides a non-destructive analysis. Alternatively, the spots are analyzed at 254 or 366 nanometer. If these compounds are fluorescent, moreover, fluorescent stationary phases may be used to if the compounds exhibit quenching properties. These days, design of UV cabinet is improved, which allows fixing of digital camera so you can click the photographs, recording the images. Further, the component may be quantified on the same plates. So friends, this is step 5, scanning. We will have another point which is quantifying. So first of all, let's see what do we mean by scanning. And scanning phenomena comes into existence just after the development of chromatogram, that the mobile phase has ran over the stationary phase and has taken samples along with it and has tried to separate the analytes from that mixture being placed with the help of applicator systematically at the bottom of the plate. Let's see what happens. See, you have placed it inside.
It is the developmentation.
This
After
254
developmentation,
nanometer light
dry it in vacuum desiccator.
you see
Avoid
from the
using
top.
hair dryer or else the essential oil components will evaporate.
See, a very good statement has been given over here. When we go for a rational TLC, the traditional method, sometimes I have seen people that after the run of mobile phase, they will dry it in the oven or they will dry it with a dryer. It can be done only for those substances which are least volatile or which are not essential oils. But friends, Hptlc is generally used for natural product chemistry. And in natural product chemistry, essential oil, fragrances, perfumes, etc., which are naturally available, are highly volatile. So even if you will try to dry that plate which was wetted by mobile phase with a hair dryer, you might lose some volatile essential oils or fragrances. So never use such kind of things. Just take it out from that bottle or from the chamber which was filled with mobile phase. Your chromatogram development has been completed and now you keep it outside for a while to dry and directly place it in this scanning visualizer.
Keep it in visualizer at 254 nanometer.
It is
It
254
is at
nanometer
366 nanometer.
and then this is 366 nanometer. It is something like a UV range and a
If
visible
the
range.
sample is not of non
Sometimes when the spots are not visualized, as we saw in TLC, we used KMNO4, we can use iodine, we can use ninhydrin. Similarly here, it can be derivatized by using 10% H2SO4 solution. And you can see the spots are visible very clearly at this point. So the spots which were not visible earlier can be made visible by reacting it with H2SO4, but this now becomes a destructive method and the earlier method of scanning with the UV or visible light was a non-destructive method.
UV observing type, it should be immersed in H2SO4 for derivatization, but it should not exceed 10 seconds. and again air dry. The bands are appeared in it and we should compare that.
So this is a natural product experiment. And then you can go for your computer and you can get the data. Again, step 5, there is one more advanced method of scanning. So we will just go through that advanced method of scanning. Let us again go through this video. This is the second video of the same procedure, scanning.
Low noise, high dynamic range images.
See again, the green image which is over here in the back posture of the video is a clean image with no spots. But after the experiment, see what happened.
With the image comparison viewer, tracks originating from the same or
Friends, these are the separated components that can be observed through a computerized visualizer or a scanning machine. This is not a sketch, it's a real picture, and such kind of things are possible. I have visualized them during the course of my learning, and these are fingerprints. These are different fingerprints. In natural product chemistry, when it is scanned or examined through Hptlc, the title that are given to the research papers is fingerprinting of so and so extract of so and so plants. So these are fingerprints.
different plates and detection modes can be
See, this is at 254 nanometer.
compared on the same screen, side
Now the white posture was 366 nanometer.
by side, and as many as you need. The new sample-oriented approach allows for creating virtual plates from tracks originating from different plates for batch-to-batch comparison or long-term stability.
Now you yourself can imagine step 1 to step 5. What an advancement. And now you compare this advancement with TLC. Definitely you can say it is high performance. So these steps, the entry of automated machines, the increase of precision, the increased rate of accuracy, the decrement in the errors, the decrement in the human interventions can truly make it high performance thin layer chromatography from thin layer chromatography.
Testing. VisionCats controls the
So this was a second scanning video which could help you make it more clear. Step 6. You are getting the spots. But have you ever thought that these spots that have been just separated on a TLC plate can be converted into peaks? No. But this can be done when human intervention is gone and instrument intervention or computer intervention comes into existence. You are here for increasing its performance. You need to know it. Quantitative evaluation. Densitometry, separation tracks are evaluated with the help of light beam in the form of slit with adjustable dimensions. All the small components that are separated will be hit by light beams. The reflected light is measured by the photosensors, and the difference between the optical response of the blank, that is the light is thrown on the white, and light is thrown on the sample, and the difference between the optical response of the blank and the sample is correlated with various samples to calculate the quantitative data for each analyte. So this experiment based on densitometry will help us to get peak, and this peak will help us to calculate the area and height, and that will determine the quantitative presence of a component. So friends, if you go through any natural product research paper, people have today with the help of HPTLC reached to a level where they can say that in so and so plant there are 8 different components obtained, and each component or each flavonoid or each different natural product is in so and so quantity per ml of extract. This is the magic of high performance thin layer chromatography. Even as it is attached to a computer, in the computer there is a library in which there are analysis earlier done and stored of more than 2 to 3 lakh different natural products. And if you are doing with the same kind of natural products, you can compare, you can overlay, and you can judge what are the components present. So this is what HPTLC is, and for these many reasons, we really have to call it as performance. This is high performance thin layer chromatography. Still, I have something very good for you. in the coming up video. So this is the densitometer where quantitative evaluation can be done.
Quantitative evaluation of the generated densitometric data. Easily perform substance.
See, over here, from this is your main mixture, this is your main mixture, this is your analyte component 1, analyte component 2, analyte component 3, and as there are 3 components, you can see 3 major peak. So each peak is corresponding to each component separated, and the area inside this peak will help you give its quantity. And this is how a simple chromatogram can be obtained from the simple separation that has been obtained on a TLC plate. This is the magic of Hptlc, and therefore we call it as high performance thin layer chromatography.
Assignment of each separated compound at its optimum wavelength. Choose the best fitting calibration model for evaluation and quantify via peak height or area.
See the words and quantify by the peak heights or area. So the very important thing to be remembered in chromatography, in chromatogram, that the peak height and the peak area helps to determine the quantitative evaluation of any analyte. This is the report that is generated at the end of the experiment. This particular company, Chemak, is the world's best producer of Hptlc. I had an opportunity to learn it earlier when I was doing my PhD. So it's a very good opportunity. We are equally respecting this company that we could get the videos, and I have placed it over here for a better understanding between you and me. So friends, these are the different steps that when combined forms a total package of Hptlc system. Hope these video have made you understand it very well. Now combining Hptlc with other instruments is also possible. Today friends, Hptlc is again combined with chromatographic techniques and sometimes with non-chromatographic techniques. Hptlc, HPLC is a new combination nowadays in the market. Even Hptlc with a non-chromatographic technique like FTIR, Raman spectroscopy and mass spectroscopy. More and more combination, more and more better results, more and more better resolutions. So this is one of the important information that I wanted to share, that you can even combine Hptlc with different instruments. Applications of Hptlc. Hptlc is utilized for the recognition of constituents, identification and detection of impurities, and qualitative as well as quantitative evaluation of active substances. Botanical and herbal drugs. Hptlc is the best to do. Fingerprinting of pharmaceutical and plant extract. I can guarantee you that if you go on Google or Google Scholar, and if you will just type fingerprinting of pharmaceutical and plant extract, you will get 20 or 25 first page hits, and 3 to 4 hits will be using Hptlc. This is the importance of Hptlc. Forensic analysis, biochemistry, toxicology, and cosmetics. And all these applications of Hptlc are because of its properties of being extensile, steady, cost-effective, and reproducible conclusions. So friends, these properties of Hptlc has made it popular in so many areas of science, and these results are helping us to reach to a new horizon, especially in the different areas of science. So friends, I hope going through this whole package of Hptlc will have made your mind very clear that Hptlc is really an advanced version of TLC, and the P over here only stands for performance. We have tried to prove that yes, definitely really it is performing well compared to TLC. So friends, thank you once again. Feedbacks and queries are most welcome, and you can even contacting me through the phone. That is also very good. Friends, today I will just take a minute of yours, and I request you to be and complete the video today. Friends, a very serious thing that has come to our notice is yesterday That was the day 6, the day of column chromatography. Many of you friends have not given us the feedbacks. See, this is not a good gesture. You are enough capable of understanding it, so I should not elaborate it. Point number 2. There are still few friends who are attempting the quiz twice. Please do not repeat such kind of things. And I'm not talking of those who are not able to submit properly, so they are attempting twice. I'm talking of those who are trying to increase their marks. And this indirect notification to you is enough to understand what I mean to say. Point number 3. I have received many messages telling me to keep 2 different time or 3 different time of the tests, the major test. Don't worry, I'll do according to convenience of all. Point number 4, that is very important, and I am going to repeat it twice, that tomorrow, that is our 8th day, I'll be looking through the task from day 1 to day 7, and I'll be just going over all 7-day test results. I'll be searching for those who have skipped tests or have entered late, and on that context I will make an announcement on day 9 recording. If someone has missed a single test by chance, you just let me know by today. That is the day you are watching this video for the first time. That will be to be replied to me that sir, so and so test has been missed by me for so and so reason by the end of the day, that is Sunday, that is tomorrow. I'm recording it on Saturday night, so I'm speaking tomorrow, but for you it's a current day, Sunday. Apart from all this, I have received many questions from you. I am finding time and giving reply, but for that also I'm going to make a good provision on the website in the coming days. Your feedbacks are really helping me, and I am getting energized day by day to work in this fraternity of academia. Thank you once again for your patience listening.